it's Matt here with an explanation of a very specific SQL aggregation function called string ag. I'm going to show you how this function works, and then I will use it to solve a very interesting data science interview question from Amazon. To start with, the string ag function, as the part of the name suggests, is an aggregation function. Just for a reminder, the aggregation is used to reduce the number of rows in a table such that there is only one row per a distinct value from the key or from the column that we're aggregating the dataset by. We can then use a number of functions on top of the aggregation to see statistics concerning each value from the key. For example, take a look at this dataset of Oscar nominees throughout the years. There are many variables in this table, but we're only interested in the name of the nominee and the movie that they were nominated for, such like this. And now let's assume that we want to count the number of nominees that each movie had, and we can generate such an output using probably the most popular aggregation function in SQL, which is count. So we would say that we want to see the movie, and then we want to see the number of nominees, and that's we can achieve using the count function. And in SQL, the aggregation is actually performed using a group by statement. And here we say that the datasets should be grouped by a movie column, or in other words, the movie column is our key for the aggregation. And then on top of the aggregation, we actually use the count nominee function that counts for each distinct value of in our key, in this case for each movie title, in how many rows does it appear. And when we run this code, we can see that now for each movie title appears only once in the output because we aggregated the data by movie. And this is basically the simplest type of aggregation in SQL, and you've probably seen it before. But now, let's say that instead of just getting a number of nominees per movie, we actually want to get a list of nominees in each movie. Again, we need to aggregate the data because the goal is to see one row per each distinct movie title. But the aggregation function here will be different. And this time we can use this string ag function that I already mentioned. And this function allows us to concatenate all strings from the rows that have the same key value, or in our case, the same movie title. When we run this code, you can see that for each movie we have a list of nominees from our dataset. Some movies only have one name listed because there was only one nominee, but in some cases we have multiple names. The only problem that you may already see is that in the case of multiple names, such as here, there is no separation between them. We can kind of see where each name starts and ends because of the capital letters, but it's not very easily readable. And that's why the string ag function has the second parameter, which actually is a custom separator. And for now, I only put here like these two apostrophes, and this basically means that there is no separator, but we can select anything to be a separator. For example, a comma, and now comma becomes a separator between the names. We can also put, for example, a semicolon. Then we have a semicolon as a separator. We can also have a symbol and a space. So then we also have a space between the names. It can be just a space, for example, just two apostrophes and a space between them. Then each name of a nominee will be divided by a space. It can also be something like a space, then a symbol, and then another space, such like this. Pretty much any string can be here, and we can use it as a separator. So this was a brief introduction to this rather rarely seen aggregation function, and now let's see how we can use it to solve a real-life data science interview question. This question was asked by Amazon, and its title is Cookbook Recipes. We're given a table with titles of recipes from a cookbook and their page numbers. The task is to represent how the recipes would be distributed in a book. And the question then goes on to explain all the details of what the output should look like, but it's a bit hard to understand the idea just from reading this description. We were told, in fact, that in an interview with this question, you would be shown a sample of what the data may look like and what the corresponding output should be looking like. So we can also do it now. If we hit the preview button here, we can see what the input data set may look like. We only have the page number and some title of a recipe. And what we're supposed to do with it is to transform it into kind of a book, just like this. This is just the first 5 rows shown, not all of them, but still we can get the idea. If we open a book, a physical book, we always see a left page and a right page, and it would be aligned in a book. So we have some titles on the left and some titles on the right. And basically all the left pages are the even numbered pages and the right pages are odd numbered pages here. And then the additional task is to also add this first column with the page number of a left page in each row. So for example, the fondue here was on the second page, so this is why it's second, but because it's the even number, it will be on the left and not on the right. And it's also said that the first page, number 0, which is on the left, should always be left empty. In an interview, which is usually quite stressful, it's important to know the approach to a solution before we start writing a single line of code. We don't want to aimlessly start coding and just hope for the best. And that's why I will start by quickly going through and writing down the approach that I will be taking. So to solve this interview question, we can start by generating an empty series with numbers corresponding to all pages in our book. In other words, there will be a single column with consecutive numbers starting with 0 and ending with the maximum page number from our original dataset. And next, we can merge the original dataset with the series of numbers that we have created. There is a recipe title on one of the pages. We'll see the title next to a corresponding page number. Otherwise, the cell next to the row number will be empty. And then we can use a case statement, which is like an if statement in SQL, and split the recipe titles into these two columns. So the titles with the even page numbers will be in one column, and the titles with odd page numbers will be in another column. And we'll also divide the numbers from our series, so like the page numbers, by 2, so that the two recipes that will be like in an open book next to each other will have the same number in a row next to them. However, in this point, the recipe titles that normally would be next to each other in a book would be in two different rows, and we actually want to get them to a single row, one in one column and the other one in the other column. However, the only helpful thing here is that both of these rows with the two titles will have the same number in the first column. So you should be already seeing where I'm going with it, because we can aggregate the data by this number in the first column and use our string ag function to return the recipe title that needs to be on each pair of pages in the book, left and right. It will become more clearer when we start coding, but this is almost the final step. And the final step will be to add a column with numbers of the left page, so the first column that the question asks us to add, and this will be quite simple, so we'll just add this column in the end and not worry about this for the most of the time. Having defined these general steps for solving the problem, we can start writing the code. And the first step is to generate a series with numbers corresponding to all pages in the book. And in SQL, a new series of numbers can be generated using a generate series function, just like this. So this is the function, but this is what the syntax looks like. So we want to select a generate series column, and then we can call this column whatever we want. Let's call it a page number, because this is what it will represent in our case, from the generate series function. And then as parameters of this function, we specify the lowest number and the highest number that will be in this series. And just to show you how it works, for example, let's change this highest numbers to 0. So now we'll see that it will return basically the series with consecutive numbers from 0 to 5, because this is what we find here. But in our case, we want to return a series with the numbers from 0 to the last page number in our book. And what will this number be in our case? Well, we need to get it from our original data set. But be careful, because it won't be equal just to the number of rows, because as you can see in the original dataset, which may look like this, we don't have all the page numbers listed, only these where there is actually a recipe title on that page. And if there is no recipe title on a page, then this page is not listed. So we have just a few rows, but actually many more page numbers in the book. So actually, to find this page number, the maximum page number, we can use a maximum function. So I'll delete this for now just to show you that we can use something like this. So we want to select the maximum page number from our original dataset cookbook titles, and it will return the number 15. So there is 15 pages. But now how to use this inside our generate series function. So let's come back to this. So we can use actually a little trick here and paste this entire query that I wrote before, so like select maximum page number, instead of this second parameter of our function. So I will paste it like here and then like this. It's basically the entire query that just returns the number 15 in our case, and I just paste it inside the generate series function. I need to put it within, like inside the parentheses. This is important. But now the function generate series return a series of numbers from 0 to whatever this query returns, in our case 15. So if we run it, we'll see the, as we expect, the consecutive numbers from 0 to 15. Before we start the next step, which is to merge the original table with this series so that we add the recipe titles to correct page numbers, I will just put this whole thing into a CTE, common table expression, just to make it more readable. So this is the CTE, let's call it series because this is what it is. And then to access the results from this CTE, we can just put something like this. So select this asterisk mean all the columns, but there's only one from the CTE series. So when we run it, we get the same result exactly, but it will be more readable like this. So moving on to the next step, to merge the two tables, we can use a join keyword in this from statement. So now we only select from series, but we can join, merge the series with another table. So it will actually look something like this. So we select again everything from series, so from this column with numbers from 0 to 15, and then we merge it with our original dataset on the page number column so that the page numbers always match. And if we run it, we see that it's not exactly what we wanted, because we're back to not having all the pages listed, but only these that have recipe titles on them. And that's because I wrote join, and this implies in SQL an inner join. And an inner join returns such rows where the page number exists in both tables. What we need, however, is to have a left join. And so I will put left here, left join, and left join preserves all the values from all the page numbers from the series table in our case, because it's like the first one, so it's a left one. Then the cookbook titles is the right one, so even if some page numbers don't exist here, they will still be preserved. So if we run it, this is much better and exactly what we wanted. So even if some pages don't have recipes on them, we still have them listed. It's just then the blank spot, we don't have any title listed there. So this is much better. And again, for the readability, I will put this whole thing in a common table expression to make it readable, more readable, and to be able to reuse it. And also I will only select the first and the third column from this, so that we'll only have this page number and the title. We won't have this middle column because we actually don't need it. Then we also need a comma here, and to access this in the next step, we can just put that we select everything from this common table expression. Let's call it cookbook titles version 2 because it's just a little changed original data set, and we select from this table. And if we run it, we can see exactly the same thing, but only the first and what used to be third column, just for the sake of readability. And then we can continue from here. Now this is when the things get a bit more difficult. Right now we have all the recipes in a single column, but eventually we want them in two different columns depending on their page number. And to get closer to this goal, we can use a case statement. This is a little bit like a if statement from other programming languages, but in SQL. And we'll actually use two case statements. The first one will say that if a page number is even, then we want to return the title of a recipe. What I actually say here is that when the page number modulo 2, this percentage sign is a modulo, the page number modulo 2 is equal to 0, and this basically means if a page number is even, is divisible by 2, is even, then we return a title. And this whole case statement, it will basically create a new column in our table, and we can call this column whatever we want. This is this S here, so I will call it left title because that's what it will represent. And it will create a column in which if the page number of a title, of a recipe title, is even, then it will return this title, and if the page number is odd, it will just leave a blank spot. So just to show you how it works, this is the new column that we have just added using this case statement, and we can see that if page number is odd, then we don't have anything here, we have a blank space, and if the page number is even, then we return the title of the recipe that is on that page. And then we can use the same, pretty much very similar case statement to do the same thing, but for odd pages. So I will copy and paste it and then slightly change it. So we have again case when the page number is, this time we want to say it's odd. So it's page number modulo 2 is equal to 1. So it's not divisible by 2. Then we return the title, and we can call this column to again create a new column. We can call it a right title. it will look something like this. This is the new column that we have added, right title, and we can see that if the page number is odd, then we return the title. If the page number is even, then we're not returning anything. So it's exactly the opposite of this left title column. So now I will actually remove this title column, this one, the second one, because we have already all the titles and we have them nicely split into two columns as we wanted them. And also, as I suggested here in the approach, I will divide this first page, this first column, page number by 2. So how I'll do it, I will remove this asterisk here and I will replace it with the page number, so this column, but I will have it divided by 2, all the numbers in it divided by 2. And what will happen now, it will look a bit strange, but actually quite similar to what we want the final output to be. What these numbers actually mean here in the first column is that when we open our book, we first see the blank page on the left side, and then the title Scrambled Eggs on the right page, on the right side. Then we turn the page and we see on the left side the title Fondue, and on the right side the title Sandwich, and so on and so on. This is what these numbers represents. If these numbers are the same, this means that these two titles, the left one and the right one, will be next to each other in an open book. And eventually in the final output, we want both of them to be in the same row. So to reduce the dataset such that all the rows with the same value here in the first column will become a single row, we need to aggregate the data by this first column. So in SQL, again, the aggregation is made using a group by statement. So this is this step actually, and we want to aggregate or group by this first column, so page number divided by 2. So this is exactly what I write here, but this is not enough because we still need to apply some kind of aggregation functions to the other two columns, so to this column and to this column. And as you may have guessed, the function that will do perfectly in this case is the string aggregation. So what we'll do, I will just put the string aggregation, the entire case statement inside a string aggregation function. So I need to end the function here, and the same thing with the second case statement, just like this. Perfect. As you can see, it has slightly changed the order of the values in the first column. So right now, like, the titles are correctly arranged, as in like left and right title, but they're not in the right order. So I can force it to order the data correctly by adding this line. This is not necessary, but this is just for you to be able to easier see what's going on here. And yeah, this is the aggregated or the reduced data set. And we see that before we had like several rows or 2 rows with the value 0, then with value 1, with the value 2. Because we aggregated, we have 1 row for each value, and then all the titles that were corresponding to this value are nicely in the 1 row. So this means that if we open the book, first we see blank first page and then the Scrambled Eggs title on the right side, and then we turn the page, we see Fondue on the left side, Sandwich on the right side, and so on. And what's interesting is that while we are using the string aggregation functions, we're not actually concatenating any strings together. That's because each double page in our book has at most 1 title on the left and at most 1 title on the right. This is the simplification that they made in this interview question. But if it was possible to have multiple titles on the same page, we could use the same method, and the string aggregation function would concatenate these functions for us. So for example, we could have Fondue and then something else on the same page, but this is not the case in this interview question. So the reason why we're using this specific aggregation function is simply because we need to use some kind of a function, and this one allows us to preserve the original strings without changing them. Also for this reason, it doesn't matter what I choose to be a separator. As you can see, I just put like 2 parentheses, which means no separator, because we're not actually concatenating any strings, so no separator is necessary. It wouldn't change anything. Though it still needs to be included. So this parameter, the second parameter, it still needs to be included in the function, otherwise this function wouldn't work. And yeah, and the final step is to add column with the number of the left page in each row. This is what the interview question requires us to do. So instead of this 0, 1, 2, 3, it actually would be 0, 2, 4, 6, 8, and so on. So all the even numbers. And yeah, we already have these numbers here in the first column that go from 0 to 7, but they are consecutive. They are not only even numbers, but we can easily reuse them. So we can just take this, the first column, which is here, page number divided by 2. Then to make it even, we can multiply it by 2, and let's give it an alias left page number. And yeah, this is exactly what it did. We have now all the even numbers. And I know that this expression here looks a bit strange, like first we divide by 2 but then multiply it by 2, but the reason is that we aggregate the whole thing by the expression page number divided by 2. So in the select statement somewhere we need to preserve this page number divided by 2 before we actually start doing anything with it. It needs to be exactly the same, so otherwise the SQL would return an error and you will need to modify the aggregation key, which however will change the results to something incorrect. So let's just leave it like this. It works. So let me just make it clearer that actually here we do this and we divide by into 2 columns by this. I hope this makes sense, even though that the steps are not exactly how the code is structured. But yeah, here it is. This is the correct answer, hopefully. Yes, to this interview question, and this is the complete solution that uses 2 common table expressions, one here and one here, and then the main query with the data aggregation and twice the string aggregation function, because we needed to use some aggregation function on top of the aggregation. I hope you enjoyed this explanation and learning how string aggregation function works and how to use it during technical data science interviews. I showed you one possible solution to this interview question, but there are also other possible approaches and solutions, and also other ways in which you can use the string agg function. So my advice is to practice answering the interview questions by constructing solutions to them, but always thinking of other ways to solve them. Maybe you'll come up with a more efficient or more elaborate approach. That's it from me today. If you'd like to see more videos like this one, check out this channel and the playlist with many more data science interview questions. Also, make sure to subscribe to this channel to stay up to date when we publish new content. Thank you, everyone.